Hello everyone, welcome to my channel. Today we will talk about colloidal solution. So what is a colloidal solution? It is a homogeneous looking heterogeneous system which contains particles of intermediate size. Means here the particles will be bigger than true solution particle, they will be smaller than the suspension particles. So with colloids, there are two terms closely associated. One is dispersed phase, another is dispersion medium. So what is dispersed phase or internal phase? It is a component which is present in small amount, in small portion. Whereas the dispersion medium is the component which is present in excess amount or in the large amount. So we can say similar to solution, dispersed phase is equivalent to the solute and dispersion medium is equivalent to the solvent. So a colloid is a heterogeneous system in which one substance, that is dispersed phase, is dispersed as very fine particles in another substance called dispersion medium. In a colloid, dispersed phase may consist of particles of single macromolecule, for example protein, carbohydrate, or an aggregate of many atoms, ions or molecules. Colloidal particles are larger than simple molecules but small enough to remain suspended. Let's come to now classification of colloids. Now colloids can be classified by different ways. So there are three types of number one is on the basis of physical state of dispersed phase and dispersion medium. Number two is nature of interaction between dispersed phase and dispersion medium. And number three is type of particles of the dispersed phase. So let's start the classification based on nature of interaction between dispersed phase and dispersion medium. So on the basis of it, we can classify the colloids into two types. One is lyophilic colloid and another one is lyophobic colloid. Lyophilic, lyophobic. So the colloidal solution in which the particles of the dispersed phase have a great affinity or love for the dispersion medium. Those colloids are called lyophilic colloids. Lyophilic means liquid loving. So liquid loving colloids are lyophilic colloids. So since they are liquid loving, so they can be easily formed the moment dispersed phase is mixed up with the dispersion medium. Now these colloidal solutions, when get precipitated, they can be converted back to the colloidal form simply by adding dispersion medium. Therefore, they are considered as reversible solutions. Now, if the dispersion medium is water, we call lyophilic colloid as hydrophilic colloid. For example, glue, gelatin, starch, rubber, etc. Next is lyophobic colloids. Now the colloidal solution in which the particles of the dispersed phase have no affinity, rather have hatred for the dispersion medium. They are called lyophobic colloids, means liquid hating colloids. They don't have any affinity. The dispersed phase and dispersion medium, they don't have any affinity for each other. Now their colloidal salts can be prepared only by special methods, not simply by mixing, because there is no affinity, there is no force of attraction between the dispersed phase and the dispersion medium. For example, solutions of metals like silver and gold, aluminium hydroxide, ferric hydroxide, etc. So they are formed with great difficulty and they are irreversible in nature, means once they get precipitated, they cannot be converted back into the colloidal state by simply adding the dispersion medium. They cannot be converted back. So that's why they are irreversible, means they cannot be reversed. And how to precipitate these solutions, how to coagulate these solutions? Their coagulation can be done on the addition of small amount of electrolytes, or by heating, or by shaking. So they are not stable. Next is classification of colloids based upon molecular size. So number 1 here is the multi-molecular colloid. Number 2 will be macromolecular colloid. And number 3 will be associated colloid. So let's begin with the multi-molecular colloid. So on dissolution, large number of atoms or smaller molecules of a substance aggregate together to form species having size in the colloidal range. Colloidal range is 1 to 1000 nanometer. The species thus formed are called multi-molecular colloids. For example, gold solution or gold sol, sulfur sol. S8 means 8 atoms of sulfur combined to form S8 molecules. Number 2 here is macromolecular colloids. Macromolecular colloids means the particles of the dispersed phase are sufficiently big in size to be of colloidal dimension. They are usually the polymers or macromolecules. So that's why they are called macromolecular colloids. They are quite stable. They resemble true solutions in many aspects. For example, cellulose, protein, and enzymes. Next is associated colloids or micelles. Now there are some substances which at low concentration behave as normal strong electrolytes, but once the concentration increases, they exhibit colloidal behavior due to the formation of aggregates. The aggregated particles so formed are called micelles, and these are called associated colloids. Now the micellar formation takes place only above a particular temperature called Kraft temperature and above a particular concentration called critical micelle concentration CMC. On dilution, these colloids revert back to individual ions. Surface active agents such as soaps and synthetic detergents belong to this category. For soaps, CMC is 10 raised to the power minus 4 to 10 raised to the power minus 3 mole per liter. And these colloids have both lyophobic and lyophilic parts. So micelles may contain as many as 100 molecules or even more than this. Next is mechanism of micelle formation. So here we will discuss it in context to soap solution. What are soaps? Soaps are sodium or potassium salts of higher fatty acids, and they have got the general formula RCOONA or RCOOK. Now when soaps are dissolved in water, this molecule will dissociate into ions, RCOO negative ion and Na positive ion. RCOO negative ion consists of two parts, R, which is the hydrocarbon part, COO negative, which is the polar group. Hydrocarbon part is the non-polar tail, whereas COO negative part, which is a polar group, is hydrophilic. Hydrophilic means water loving. Hydro means water, philic means loving, phobic means hating. So hydrophobic part is hydrocarbon part, which is a non-polar tail, whereas the head, that is carboxylate group, which is polar group, is hydrophilic, means water loving. This is a structure of an ordinary soap molecule having long hydrocarbon chain, which is hydrophobic, having polar head, which is hydrophilic, means water loving. Now when RCO negative ions are therefore present on the surface with their carboxylate groups in water, and the hydrocarbon chains are staying away from it, and remain at the surface. But once the concentration increases, means it reaches critical micellar concentration, then anions are pulled into the bulk of the solution and aggregate to form a spherical shape with their hydrocarbon chains pointing towards the center of the sphere and carboxylate part remaining outward on the surface of the sphere. An aggregate thus formed is known as micelle. Micelles may contain as many as 100 such ions. And same is true for the detergents. See, when the concentration is low, the polar heads are facing the water. When the concentration has been increased, it has reached critical micellar concentration. Now the molecules will enter into the bulk. And here it has entered into the bulk, whereas all the hydrophilic head now will point outward, whereas the hydrophobic tail will point inward in the form of sphere. This spherical structure is micelle. Let's discuss now cleansing action of soap. Cleansing action of soap is based on hydrophilic and hydrophobic part. And the cleansing action is due to the fact that soap molecules form micelle around the oil droplet in such a way that hydrophobic part will be pointing inward and the hydrophilic part will be pointing outward. Since the polar groups can interact with water, the oil droplet surrounded by stearate ions which come from the soap here is now pulled in water and removed from the dirty surface. Soap helps in emulsification and washing away of oils and fats. The negatively charged sheath around the globules prevent them from coming together and forming aggregates.